I'm Austin Ziegler, and my partners are Tracy Salgado, Anthony Gallett, and Garrett Oswald, and we are Squad L. The initial direction was to help provide Amazonian natives to have access to clean drinking water. This direction was chosen because each member of the team was interested in a water resource project. There are many problems with the water the Amazonian natives drink today. It's a facilitator of many illnesses, as the Amazon River is the main consistent source of fresh drinking water. One of the main problems with Amazonian drinking water today is that it is contaminated with microorganisms. Shown in the picture is a Giardia parasite, which causes diarrhea, vomiting, and fatigue. This parasite is commonly found in the Amazon, and preventing its consumption is a goal of the teams. Another issue is the large amount of sediment suspended in the water, composed of soil, garbage, decomposing plants, and fecal matter. When ingesting large amounts of sediment, the digestive tract can be compromised. Preventing consumption of sediment is another team goal. Secondary factors that we are taking into account are runoff from illegal mining such as mercury and iron minerals, invasive insects, and carrier species contaminating pools of calm water where drinking water is most commonly drawn and stored. The initial design challenge of how might we provide access to clean potable water to the remote villages on the tributaries of the Amazon River was concluded and agreed upon by the team to meet goals of cleaning the water along with helping those who have not yet been helped. The group wanted to focus on what resources were available to Native community and how to best use them to make cleaner water. This shifted the focus from a large intervention to an instructional and self-sustaining cleaner water source. After interviewing experts, the group found it was best to focus on a simple and cost-effective system that could be taught to a large population and self-sustain its own growth. This could include a startup, team building, along with an education on how to recreate the system. Taking valuable information from the experts, the team set out to make a filtration system using these main goals: educating, building using natural resources, allowing it to integrate into the culture from which people will then share and educate others, allowing the cycle to repeat. Using the goals that the team has set, the final design challenge was determined to be how might we use local and natural resources in a water filtration device that is both easy to use and accepted by the Amazonian people. The designs that were made use the human-centered design process, which focuses on designing a system that addresses the needs and problems of a person or community. We disregarded complex ideas and refined simple solutions.
The two final design projects that the group came up with are, first, the most innovative, the bank and charcoal filtration with a bamboo pump. Second, the most likely to succeed, the raincatcher water storage with chemical sterilizers. The most innovative idea consists of a bank filtration with a bamboo hand pump in line with a charcoal filter. This idea, since it is made of local natural resources, allows anyone who can gather the materials to create a system for cleaner drinking water. The bank filtration works by digging a well and lining it with a clay that allows water to seep through that does not have sediment. The water is then brought up by a hand pump made of bamboo. The pump is made of bamboo because it is a natural resource which is better than bringing in pipes that could corrode and would have to be replaced in time. This pump then feeds into a charcoal filter. The charcoal filter filters out the remaining sediment and microorganisms, producing clean, potable water. The filter is composed of a series of layers consisting of gravel, sand, and charcoal. The most likely to succeed idea consists of the raincatcher and storage container with chemical sterilization. The raincatcher is a simple idea of catching and storing non-sedimentary fresh water. This idea is well dated and is already accepted by the community. In an attempt to neutralize microorganisms in the storage water from collected rainfall, chemical chlorine has been deemed the best option for the price. The downside is that the chemical must be delivered and properly used into the water, which requires education. The positives about the bank and charcoal filtration idea are that it is made from natural resources found in the Amazon, along with having little invasion to the cultural environment. The rainwater storage and chemical cleaner are more effective for cleaning the water, but requires a high expense for upkeep, as well as more initial cost and manual labor to build storage and collection structures. In the end, both Tracy and Garrett are very interested in the bank filtration, while Anthony and Austin are interested in the bamboo pump. Anthony is also interested in pursuing the charcoal filtration.